Hi folks, welcome to the Math 521B Key Concepts video series. In this video we're looking at Chapter 1, Sequences and Series. You may want to pause and just look at the disclaimers for a second. The main one is that if you're using this to teach yourself the material the first time, it's really not intended for that. It's intended as a review, so you may want to look at Martin's Math, which is an excellent channel on YouTube that supports Pre-Calculus 11. Okay, let's dive in. Arithmetic sequences. A sequence is an ordered collection of numbers. Sequences that increase or decrease by the addition of a fixed amount are called arithmetic sequences. The fixed amount is called the common difference, and the letter we use for it is D. So let's take a look at some sequences we've got here. 3, 7, 11, 15. You can see that the pattern here is adding 4 every time. The next term would be 19, and so on. We would say D, or the common difference, is 4. The next one we have 4, 2, 0, negative 2. You can see the patterns going down by 2 here. So negative 4, then negative 6, and so on. And in this case, we'd say the common difference is negative 2. We're adding negative 2 to get the next term. Generally, the common difference is tn plus 1, so the n plus 1th term minus the nth term. But the easiest way to conceptualize that is as the second term minus the first term. So if I use this, say, in the first sequence we had, the second term was 7, the first term was 3, and guess what it gave us? It gave us 4, the common difference. If we weren't sure, we could just subtract those two terms. And in an arithmetic sequence, the difference between any two successive terms are going to be the same. Okay, some things to notice. T2 is just the first term plus one of these common differences. T3 would be the first term plus a common difference gets us to the second term, plus another one gets us to the third term. So this would be a way to express T3, T1 plus 2D. And that's going to hold true as a pattern throughout. Now we will end up with a formula for the nth term in any sequence, any arithmetic sequence, but it's good to have this intuitive understanding as well. So let's put that to use in an example. The 7th term in an arithmetic sequence is 13, and the common difference is negative 4. We're looking for the 10th term. So we want the 10th term, and we know something about the 7th term. What would you have to add on? Well, let's see. If I add on a D, I'm at the 8th term. Another one, and we're at the 9th term. Wow, another one, and we're at the 10th term. In other words, T10 is T7 plus 3D. Once we have that equality, we can substitute in. So what do we know? We know T7 is 13, the 7th term. We know the common difference is negative 4. And this whole thing is what T10 is. That's 13 minus 12, or 1. Now you might have another way to get there. You might actually write out this piece of the sequence. That's fine, but we do want to have some sort of analytical techniques. And let's do an example to show why. The 9th term in an arithmetic sequence is 8. The 15th term is 22. We want to find what the common difference is. So you might guess that, I don't know, that the difference is 2. And you go, okay, if it's 2, then I have 8, 10, 12. This is my 9th term right here. 14, 16, 18, 20. Okay, this is 10th, 11th, 12th, 13th, 14th. Oh no, 2 didn't work. Boo. And if we guess and test, it's going to take us a long time. And we may never come up with the right number. So a good way to think of this is the 15th term is the 9th term plus 6 of those D's. Okay? One of them would get you to T10, 2 would get you to T11, and so on. At that point, we can just sub in. T15 is 22, T9 is 8, and solve for D. So we subtract 8 from both sides. We divide by 6, and we end up with D is 14 over 6, or 7/3. And I don't know about you, but I never would have thought to guess 7/3. So we have a method here. Okay, let's move on. The general term of an arithmetic sequence is given by this formula. And this is given to you in your formula booklet for your secondary math assessment. Here's what it means. Tn is the nth term. It could be the first term or the 9th term, the 25th term. T1 is the first term. I think that's pretty intuitive. This is the one that seems to cause the most trouble. What n is. N is the term number. Like it could be the 4th term. So n would be 4 if that were the case. Or 11th. N is 11 if we're talking about the 11th term. So it has to be a whole number that's positive. Can't be negative. You can't have a negative first term. Can't be a decimal. You can't have a 2.7th term. There's just a first, a second, a third, etc. All right, now that we've got that, let's put this formula to use. We want to find the general term for this sequence. And general term just means a simplified formula for that particular sequence. Whenever I run into these problems, what I like to do is catalog what I know. So I know the first term in this sequence is -4. And the pattern is -4, -1, 2, 5. Aha! We're going up by 3s. So the common difference here must be 3. That's what we know about the sequence so far. So now let's use that formula that's given to us. Tn is T1 by n minus 1 all times d. Substitute in what you know. T1's -4. D is 3. And we're going to put this in the prettiest possible form. So we'll simplify it. Plus 3n minus 3. In other words, the nth term, or the formula for some term in this sequence, is going to be -7 plus 3n. Okay? Now if we want, say, the 150th term, we can just plug into that formula. In this case, we're asked for the 47th term. So we could go all the way back to here and use this formula again. But we've already got a simplified version. Let's plug into that. T47, meaning the 47th term, is -7 plus 3. Well, what is n here? Ah, it is the value here. We're talking about the 47th term. So n is 47. And at this point, we're just going to head to a calculator. We'll figure out that 47 times 3 is 141. Minus 7 is going to be 134. Now, it might be some other variable that we're looking for. So over here, we have the arithmetic sequence where T1 is 6 and T14 is 58. So when we see this, we think n is 14. Okay, and this would be our Tn. The T14 is 58. So we can use our arithmetic sequence formula to find any of the 4 letters in it, provided we know the other 3. In this case, T14, or Tn, is 58. T1 is 6, and n is 14. So we're going 14 minus 1 times d. Let's work this out. That's 6 plus 13d. We can subtract 6 from both sides. And finally, we'll divide by 4, or by 13 rather, and we'll get 4. Divide by 13. The common difference must be 4. If you like, you could have used the more intuitive way that we started off with and said, oh, well, I know T14 is just T1 plus 13d. It's going to get you to the same place. But we can use this formula if we like. As long as you know 3 of the letters, you can find the last one. So similarly, how many terms are in the sequence? So in this sequence, I'm cataloging what I know. T1 is 40. D, we're going down by 2's, so D is -2. This final term right here, that is the nth term. And the thing we want to find, it's asking us how many terms. is what is n? So I'm going to write down the formula, which once again is given to you. And we're going to solve for n. Tn is negative 24. T1 is 40. Plus n minus 1 times d, which is negative 2. Let's work that through. So that's minus 2n plus 2. Should have given myself a little more space here. Negative 24 equals 42 minus 2n. Okay, subtract from both sides. We'll have negative 66 equals negative 2n. And when I divide by negative 2, I'm going to get 33. There are 33 terms. Notice my n is a positive whole number. I need it to be that way. If it works out to be a negative or a decimal, then we've probably done something wrong. So n equals 33. There are 33 terms. One last one, a fairly straightforward application. Alessandro can run 5 kilometers. Every week he wants to add a half kilometer to his run. During what week should Alessandro expect to run 12.5 kilometers? So right now, he can run 5. Every week, we're adding a half kilometer. That's the common difference. And there's some week where he expects to run 12.5 kilometers. So our only question is that n or is it Tn? It's the value of a term. It's not talking about the 12.5th week or something. It's the value of the nth term. So it must be Tn. And the thing we're looking for is n, how many weeks this is going to take. So the first week is 5 kilometers, and so on. So once again, we can set this up with our magic formula. 12.5 equals 5. By n minus 1, n is unknown. By 0.5. Okay, and we'll clean that up a little bit. 5 plus 0.5, n minus 0.5. So 12.5 equals 4.5 plus 0.5n. Subtract 4.5 from both sides, and we get 8 equals 0.5n. You can either divide by 0.5 or multiply by 2. And we get n equals 16. There are going to be 16 terms in that sequence by the time you get to 12.5. So 16th week. Okay, moving on to arithmetic series. A series is just the sum, and remember sum means add, of the terms in a sequence. An arithmetic series is the sum of the terms in an arithmetic sequence. Shocker. There are two versions of the formula for the sum. So the sum of the first n terms is given by Sn. S for sum. Now sometimes people ask, well, which one do I use? Well, it really depends on what information you know. And we'll use the next two examples to sort of flesh that idea out. Find the sum of the first 100 positive even numbers. So let's start writing them down. 2, and then we'd add on 4, and 6, and 8, and so on. In this series, we know that T1 is 2. The common difference, to get from 2 to 4, you add 2. 4 to 6, you add 2. 6 to 8, you add 2. So D is also 2, coincidentally. Okay, and now we're looking for the sum of the first 100. That means n is 100. If we look at that set of information, it's either this one in green or this one in red that we use. We know T1, N, and D. We better use the one in red, the one that actually has that information. So we're saying S100 is going to be 100 over 2, 2 times T1, which is 2, plus N minus 1, so that's 100 minus 1, times the common difference, which is 2. let's get a little practice putting that into our calculator. So the more stuff you can do in your head, the better. 100 divided by 2, that is 50. Times 2 times 2, oh, that's 4. Plus 100 minus 1, that's 99, times 2. Okay, the more of that simplification you do yourself, the less bracket problem you'll run into. And we get 10,100. So that's the sum of the first 100 even numbers. Let's take a look at another one. An arithmetic series has a first term of 15 and a last term of negative 28. We don't know any of the terms in the middle. Find the sum. And there are 12 terms. So again, we'll catalog what we know. We know T1 here is 15. We know, well, we want to say Tn, but really it's the 12th and last term. T12 is negative 28. And n is therefore 12. There are 12 terms. The last of those 12 terms is negative 28. So let's take a look at our two formulas up top, green or red. Well, here we know T1 and Tn. We must use the green one. We could use the red one, but we'd have to go and find D. It would be more cumbersome. Okay, so in this case, we're looking for S12, the sum of the first 12 numbers. I'm just subbing them into this formula up here. So that's 12 over 2 by T1, which is 15, plus negative 28. Okay, and again, I'll put that in my calculator, but I'm going to give my calculator the fewest opportunities to give me a hard time. So 12 divided by 2 is 6, times 15 minus 28, that's negative 13. Boom, negative 78. Okay, this is a kind of classic question. Find the sum of the first of all the multiples of 7 from 1 to 500. So again, if I'm not sure what's going on, I'll write out part of the formula. This is going to be 7 plus 14 plus 21 and so on up to, well, actually, we don't know how far it goes up to. We'd have to know that last multiple of 7 just before 500. Now, you can guess and check that number if you need to, but I'll show you a way that you could actually figure out analytically what the biggest multiple of 7 that's under 500 is going to be. So let's take a look at what we know. T1 is 7. D is 7 as well. Okay. Tn is just under 500. We don't know exactly how many under 500. One thing we could do is just substitute 500 into the formula, which is Tn equals T1 plus n minus d, n minus 1 times d. Okay, we don't have enough information to be able to use an Sn formula. Later we'll find the sum. So step 1 is find that last term. Okay, so I'm going to sub in 500. It may or may not be part of the sequence. I don't know. N minus 1, D is 7. I'll simplify this. Plus 7n minus 7. 500 is 7n. And then we'll figure out what n is. So if 500 were part of the sequence, we'd be looking at the 71.4th term. Hold on, you can't have a 71.4th term. There's no such thing. So can't have a decimal term number. Therefore, we're looking at the first 71 terms. Okay, n equals 71 up to 500. Now that we know that, because going to 72 would exceed 500, now that we know that, we can use one of our SN formulas. Okay, so see, we know N, T1, and D. We can use this SN formula. 2 times T1 plus N minus 1 times D. And we're looking here at the 71st for 71 terms. So that's going to be 2 times T1 of 7 plus 71 minus 1 times 7. And we can head to the calculator, and it's going to give us 17,892. And you might want to double check that you can do that in your calculator. Okay, one last application that we'll do in this video, and then we'll cap it and have a second video on geometric sequences and series. A theater has 12 seats in the first row, 14 seats in the second row, 16 seats in the third row, and so on. How many seats are in the ninth row? Let's write out the sequence. We have 12 in the first row, 14, 16, and so on. So when we catalog our stuff, we say first term is 12, common difference is 2. If we're talking about the ninth row, then n is 9. The only question here is, are we looking for a term or are we looking for a sum? How many seats are in the ninth row? That's a term in the sequence. It's just one of the numbers. So we're looking for T9, which is going to be T1 plus n minus 1. So 9 minus 1 times the common difference of 2. Okay, that's just coming from our term formula. And from there we can solve pretty easily. T9 would be 12 plus 8 times 2, or 12 plus 16 makes 28 seats. Okay, the next one asks how many seats are in the first 9 rows. This is in total. And if you can think of it in terms of in total, then it's probably a sum question. And we can use either of our sum formulas. Here we know T9, and we know n, and we know T1. We might as well use this one. But you could just as easily use the other one. It's up to you. It'll work out the same way. So S9 would be 9 over 2, T1, which is 12, plus Tn, well, that would be T9 in this case, of 28. Okay, so that's 9 over 2 times 40. And we could probably do this faster in our head than with a calculator. 40 over 2 is 20, times 9 gives us 180. But you're certainly welcome to use a calculator. I hope this has been a good review of sequences and series for arithmetic. In the next video, we'll look at geometric sequences and series. See you soon!